Today we're taking a look at section 4-3 on the addition rule. At the end of this section you should be able to do the following. You should be able to define what a compound event is. You should be able to state and apply the formal and intuitive addition rules. You should be able to explain what is meant by mutually exclusive or disjoint events. That should be by. You should be able to state and apply the rule of complementary events. A compound event is defined as any event that combines two or more simple events. And commonly, if you're adding the word or the word and, that's when you would have a compound event. Okay, so the probability of A or B is defined as the probability that event A occurs or event B occurs, or they both occur. And if we look at the formal addition rule, which is our first formula of this section, if A and B are any two events, then the probability of A or B is the probability of A plus the probability of B minus the probability that A and B both occur. So if you look at Venn diagrams from set theory, it kind of helps us to understand what's happening. Suppose we have 5 elements in the part of A outside of B, 3 elements shared by A and B, and 7 elements in the part of B that's outside of A. We talk about the element in A or B, also known as the union of A and B. We would add the 3 numbers. 5 plus 3 is 8 plus 7 is 15. Now notice if I talked about and I just added the number in A plus the number in B, what will happen? The number in A is a total of 8. Number in B is a total of 10. And that gives us 18. And the reason that's 3 more than it should be is because we double counted the 3. So we also have to subtract the number in A intersect B. And this is the same sort of situation if we're counting the ones in A and the ones in B, and we may be double counting any that occur in both A and B. So that's why we have to subtract that off. So looking at an example, a single card is drawn from a deck of 52 cards. What is the probability that the card drawn is a face card or a heart? Well, a face card, there are 12 face cards, Jack, Queen, King, times 4 suits, that's 12 face cards. There are 13 hearts, so if we add 12 over 52 plus 13 over 52, we're going to get 25 over 52. But recognizing that we double counted the face cards that are hearts, there are 3 of those, we have to subtract the probability of getting a face card and a heart. So we want to subtract the 3 heart face cards. So 25 minus 3 would be 22 over 52, and we reduce that. We get 11 over 26. Okay, example 2 I have for you to try, so you'll want to pause the recording right now and see if you can figure out the answer. When you can have the answer, then restart and we'll check your answer together. So pause the recording now. Okay, hopefully you have an answer for example 2. We're drawing a single card. The probability the card is an ace or a red card. So probability ace or red equals the probability it's an ace plus the probability it's red minus the probability it's an ace and red. So probability of it being an ace is 4 out of 52. We have 4 aces. Red cards, we have 26 out of 52. Red ace, we have 2 red aces, so we've double counted those. We want to subtract that off. So we're going to get 28 out of 52, and 4 will go 7 and 13. So hopefully you got the answer 7/13. Okay, so that's the formal addition rule of probability, formal addition rule. You can also use an intuitive approach, and I do this fairly often. To find the probability of A or B, find the sum of the number of ways event A can occur and the number of ways event B can occur by adding such a way that every outcome is counted only once. The probability of A or B is equal to that sum divided by the total number of outcomes. So if I look at example 2 again, and I'm doing that with the intuitive approach, I would say, okay, there are 26 red cards that include the 2 red aces, and I'd have 2 black aces, so I'm just counting the ones I haven't counted already. I'd get the 28 out of 52, which would put me at this point, and then I would reduce it. So whichever makes the most sense to you, stick with that particular method. Okay, mutually exclusive events are also called disjoint events. These are 2 events that cannot occur at the same time. And since I used a Venn diagram earlier to represent sets, it's kind of like you have the event A here and the event B here, and there's no intersection between the 2. That's what we mean by a disjoint or mutually exclusive. Okay, so my example, if you are drawing 1 card from a deck of cards, then drawing an ace and drawing a king would be mutually exclusive. If you're drawing 1 card, there's no way you can draw 1 card that's both an ace and a king. So that's why they're considered mutually exclusive. Okay, next we have the rule of complementary events. The probability that an event A will occur plus the probability that event A will not occur, and notice you need to put the bar over one of those, is equal to 1. So the probability of A complement is 1 minus the probability of A. The probability of A is 1 minus the probability of A complement, or not A. So I think our book uses the bar to indicate that. Okay, so a single card is drawn from the standard deck of 52 cards. What is the probability that the card is something other than an ace? So it's going to be 1 minus the probability it's not an ace. Sorry about that. It's going to be 1 minus the probability it is an ace. So there are only 4 ways to get an ace, 4 out of 52. I can reduce that to 1/13. Remember, 1 is 13 over 13, and 13 minus 1 will give us the 12/13. So see if you can figure out example number 2. We have a single die is rolled. What is the probability that is something other than a 1? Again, pause the recording while you figure out the answer and then restart it to see if you got the answer correct. Okay, hopefully you have figured out the answer. We want something other than a 1, so that's going to be 1 minus the probability it is a 1. So 1 minus probability of a 1 is 1/6, and that gives us 5/6 for an answer. So hopefully you got that one correct.